Now we are going to inspect functions for continuity, and we are going to use the two options of the 1, 2, 3, 4 and the other option that I gave you before. And in this case, we are not going to sketch the graph. We are going to analytically inspect the function for continuity. And in this case, we obviously want to check at a suspicious point, which is x equals 2. 1. We are familiar really with 1, 2, 3, so let's do it pretty fast. The limit from the right when x approaches to 2 is exists and it's 5. The limit from the left exists and it is 3, which already telling me that the limit from the right at x approaching to 2 does not equal to the limit from the left when x approaches 2, so the limit does not exist. And if the limit does not exist, we can immediately conclude that f is not continuous at x equals 2, or as we say, f is discontinuous at x equals 2. Let's do it in the other way. If you recall, 1 was to check that x equals 2 is in the domain of the function. Yes, it is. And f of 2, as you can see, I have to use the branch for the function being x cubed minus 3, and I get 5. If you recall, step 2 was to find the limit of the function when x approaches 2 from the right. And we are using the branch from the right, which is x cubed minus 3. And we get 5, which is okay, it's f of 2. But now, when we take the limit of the function when x approaches 2 from the left, we get that this is 3, which is not equal to f of 2, which is 5. And again, we conclude that the function is discontinuous at x equals 2. I would like to recall this problem that we did before. We were checking to see if the function f(x) has a limit when x approaches to -2. We were applying 1, 2, 3, limit from the right, and in this case we get 10, limit from the left, and we get 10, and 3, yeah, those two are the same. So we can conclude then that the limit of this function when x approaches -2 equals 10. Limit is about what we expect to have. In this case, if you recall, we really didn't use this part. The reason was because the limit really does not care what is the value of the function at x equals -2. This was exactly the same question as finding the limit of the function f(x) when x approaches -2. Nobody really cares about f of -2. But now I'm going to ask, is the function continuous at x equals -2? Now I really care about this one, because 1, 2, 3 is about limits, but continuous is also asking, do I have what I'm expecting to have? All 1, 2, 3 was preparing me to the expectation that f of -2 is 10. And when I look at this function, f of -2 is 12. I really care what is f of -2. This is the big difference between limit and continuity. So as you can see, the limit of the function x approaches -2 is 10. It's definitely not equals to f of -2, which is 12. I can conclude that the function is discontinuous at x equals -2. Example. If g is continuous at x equals 2, what are all possible values of a and b? This question changed all the philosophy about those kind of questions. Before, we were giving a function and we have to check if it's continuous or not, which means The answer was continuous or not continuous, and we had to do all the steps. Even though solving those type of problems is exactly as before, the philosophy is totally different. Here, I am telling you that g is continuous at x equals 2, and we have to find the proper a and b to make it such. So the question now is not, is this function continuous? The question is, how can you make this continuous? By choosing the right values for a and b. The good news is that we really have still to do exactly the same, which means 1, 2, 3, 4, 1. Limit from the right. We have to use x to the power of 2 minus 3 and we get 1. 2. Limit from the left. Now we have to use 2x plus a, and we get 4 plus a. 3. Those two limits there has to be the same, which means that 1 must equal 4 plus a. More than that, the limit of the function x approaches to 2 is 1. Now it's step 4. The limit of the function, which is 1, must equal to g of 2. So you go to the function and you realize that g of 2 is e to the power of 2 minus b. I get another equation. This equation, 1 has to be equal to e to the power of 2 minus b. So in order to make this function continuous at x equals 2, I have to solve those two little equations. From this one, I easily get that a equals negative 3. And from the second one, b has to be equals 2 because 1 equals e to the 0. So 2 minus b has to be 0. So b has to be 2. I'm going to do it now in the other way. One was to see that x equals 2 is in the domain of the function and the value of the function at 2, g of 2 is e to the power of x minus b when x equals 2. The limit from the right equals 1, and this has to be equal to g of 2, which is e to the power of 2 minus b. And I get one equation. But then I have 3. The left limit also has to be equal to e to the power of 2 minus b. The left limit is 4 plus a. So I get another equation. Now I have to solve that. Because 1 equals e to the power of 2 minus b, and also equals 4 plus a, I get first of all that a equals negative 3. And when 1 equals e to the power of 2 minus b, I get that b equals 2. Now, I'm going to ask you a really tricky question. For what possible values of a and b does the limit of g exist at x equals 2? Now we really want to focus on the one above, because the one above is 1, 2, 3, 4, when 1, 2, 3 is exactly the 1, 2, 3 is the limit. So we will repeat. The right limit is 1. The left limit is 4 plus a. For a limit, those two has to be the same. So I get that 1 equals 4 plus a. Okay, I know what is a. But what about b? I didn't use b. I don't care about the value of the function when x equals 2. So I don't care if it's e to the 2 minus b or e to whatever it is. If I do not care, it can be anything. Again, if you do not care about the value of b can be any real number.